Hi everyone, this is Mrs. Van Horn and this is the first lesson recording for IM2 August 27th. We've spent the first half of the lesson finishing up the group project or group work on the Jamboard describing the different representation of linear equations. Now we're going to go on to describing graph. So what mathematical attributes would you use to describe a graph? Well, you can describe it in terms of whether it's linear or nonlinear, where the x and y intercepts are, where the maximum and minimum points are, where it is increasing or decreasing, and finally what the domain and range is. And we're going to talk about each one of them in a minute. Let's start with linear or nonlinear. So when you look at these four graphs, which are linear, which are nonlinear? Well, what does linear mean? Well, a straight line, if a graph is a straight line, then it's linear. Notice the line right inside the word linear, L-I-N-E, and that's to say that it's a straight line. So which of these are straight lines? The first one and the last one. Which are not linear or which are not straight lines? The second and the third ones. So that tells you whether it's linear or nonlinear. What about the x-intercept and y-intercept? What is, in football analogy, when a ball is intercepted? Well, it's sort of like it's been interrupted, right? So same thing, x-intercept is a point where the graph intercepts or interrupts the x-axis. And y-intercept is points where the graph intercepts or interrupts the y-axis. So if you have a look at this graph, where is this straight line? That's the graph crossing or interrupting the x and y-axis. First of all, the green point is where the graph is interrupting or intercepting the x-axis. That's the x-axis, and so we call that the x-intercept. This red point is where the y-axis is interrupted or intercepted, so we call that y-intercept. So x-intercept and y-intercepts are points. That means we use coordinates to represent them. The first number being the x-coordinate, the horizontal position, and the second number being the y-coordinate, the vertical position. The up and down position is the y-coordinate, and the horizontal position is the x-coordinate. Okay, so this coordinate is horizontal position is -2, vertical position is 0, and the y-coordinate is 0, 2. Okay, notice that any x-intercept, wherever it's crossing, it's going to have the y-coordinate as 0, because anywhere along the x-axis, the y position, the vertical position, is going to be 0. Same thing with y-intercept. Anywhere along this y-axis, the x-coordinate or horizontal position is going to be 0. Okay, so let's talk about the x-intercept and y-intercept of this graph. I'm going to ask you to pause the video and see if you can jot down the x-intercept and the y-intercept. The answer is going to be shared in 3, 2, 1. So where are the x-intercepts? We have 3 different points where the graph is crossing the x-axis. That's the x-axis, okay? And the coordinates are 2, 0, 1, 0, and then -1, 0. Notice again, they all have the 0 as the y-coordinate. What about the y-intercept? How many times is the graph crossing the y-axis? In this case, just once. The coordinate is 0, 2. Great, I hope you got that. Now let's talk about maximum and minimum of the graph. Okay, maximum is just a point with the highest y value in the part of the graph. We're really just talking about the peaks of the mountain. Okay, where is the highest point, highest peak of the graph? So its maximum is here, and maximum is here. Okay, but of the maximum, we describe it in terms of global maximum. Global maximum is the highest y value of the whole graph. Okay, when you talk about something being global, we're talking about the whole world, right? So instead of the whole world, we're talking about the whole graph. So what about the local maximum is the highest y value in the section of the graph. So this point is, when you compare to the points surrounding this point, it is higher than the points surrounding it. So it's a local maximum, but when you compare this point to here, it's not the global maximum. So this is just a local maximum from this region. It's just a maximum from this area. Global maximum means it's for the whole graph. Okay. Well, what about the minimum? Minimum is a point with the lowest y value, or you can think of it as the dips in the graph. Okay. And again, you can have a local or global maximum or minimum. So what do you think this point is? Is this going to be a global minimum or local minimum? Well, it's going to be local minimum. Why? Because graph only has a local minimum. There's no global minimum because this graph continues forever. That's what the arrow indicates. It will extend further and further and further all the way to the ground, okay, to the center of the earth, basically. So, and likewise here, okay, so that there is no global minimum, okay, but we do have a local minimum. Just for this region, there is a dip here. Okay, so can you write down the maximums and minimums of this graph? What do you think? Okay, please pause the video and write down what you think. The answers are shared in 3, 2, 1. Okay, so we have that point being a maximum. 1, 2. Do we have any more maximums? Yes, there is another one right there. Notice that there is no arrow. It stops right there. That means that's the highest point there. So that's going to be negative 2.7, 6, okay, approximately. So, and the minimum is this point here. Which of the maximum do we know if it's a local or global? This one, is it going to be local or global? This is going to be local. Why? It's a maximum compared to the points around, but when you compare to this point here, it's not as high as that, right? Whereas this is going to be global. Okay, what about this? We have one minimum here. Is it global or local? This is local. Why? Because this graph extends further on to further down, all the way to the bottom. Okay, so that means that it goes on forever to negative infinity. Okay, so let's talk about a graph increasing or decreasing. When we think about increasing or decreasing, I want you to think in terms of roller coaster. So roller coaster, we talk in terms of roller coaster from left to right. So mathematically, we always go from left to right. How does the height change? Okay, so from this point, the local minimum to the local maximum here, the y value or the height is increasing, right? It's getting higher. It's getting more scary. So we say that's increasing from this maximum point, local maximum, to the local minimum point. The y value is decreasing, so we say the graph is decreasing in this portion from A to B, and then from B to C, the y value is increasing. Okay, so again, from the minimum to the maximum, the y value is increasing, or the height is getting higher, it's becoming more scary. So it's increasing and then finally decreasing from C point onwards. So a graph is increasing when the y value increases as the x value increases left to right. So you should be taking notes. and the graph is decreasing when the y value is decreasing as the x value increases. So x value is increasing going from left to right. See, -3 to 1, 0, 1, 2, 3. It's increasing going from left to right. What about the y value? It's decreasing. It's going from 6 all the way to -2. So it's decreasing the y value. Okay, but from here to there, it's going from -2 to 2. So it's increasing. And then from here to all the way to infinity, it's decreasing. So the graph changes direction at maximum or minimum points. The direction is changed always at the maximum or minimum points. So it's decreasing here, increasing, and then finally decreasing there. All right, so let's talk about domain and range. What is domain? What is range? Domain is all possible x values of the graph can have. How far does the graph extend? Okay, so this open circle dot circle tells me that it stops right there, and that it stops right there. If you see an arrow, that means it extends forever. However, it stops right there. And so the graph has values from x values from -3 to 1. Okay, and what about range? It's all possible y values of the graph can have. So all possible y value is the y-axis values. Okay, how far does the graph extend? It extends, the highest point is here and the lowest point is here, or lowest point is here. So you just talk about the maximum and the minimum. Okay, and again, domain is just how far does the graph extend. So range, it extends from 0 to -4. I know a lot of you get confused with domain and range. How do I remember that? So I try to remember docs and ray. My friend, docs and ray. Docs stands for domain, is all possible x values. Ray is all possible y values. So range is all possible y values. So if I just remember docs and ray, it's much easier. Okay, what does the hollow circle mean and solid circle mean? So if you remember inequality, hollow circle means that point is not included. Okay, does not include the point. Solid circle means it includes the point. So in this case, for domain, all x values are between -3 and 1. But does it include -3? No, it does not. Does it include +1? Yes, it does. Okay, so we would indicate that in an inequality like so. It's going to be -3 is less than, x is less than or greater than 1. Okay, so the fact that it's not equal to tells me that it's open circle. Okay, all right, so what about the range? All y values between -4 and 0. Can we be more specific? Okay, so it goes from 0 to 4. Does it include 0? Yeah, because it's a solid circle. Does it include 4? Oh, -4? Yes, because it's solid circle. So we would write it in inequality form as -4 is less than or equal to y is less than or equal to 0. Okay. Actually, one thing I do want to point out is when you're writing inequality in a compound inequality, make sure that you are writing the smaller number on the left and larger number on the right. Smaller being more negative, okay, or small, and so just like the number line, and the inequality sign is always going to open to the right. Okay, so domain in this case is all x values between -5 and infinity. Okay, so -5. Okay, domain is the x value. It stops right here, so it does not go any further. But notice what's happening to this arrow. It extends forever. Okay, it looks like it's vertically going down, but it actually goes down at a slight angle. So that means it's going to go on forever. So it goes from -5 is less than or equal to x is less than infinity, and then finally range is going to be -infinity is less than y is less than or equal to 5. Okay, so quickly you are going to write this down, and that is going to be the end of the lesson. Okay, thank you for watching.